folks, this is Pat at Maendeleolab back after a 2-week sprint, and today is about IPv6. So if you don't know, IPv4 public IPs are going to be increasing in cost. And what that means is it's just going to cost a little bit more to operate. So a lot of us, we're thinking ahead. It's probably the time to really start looking at IPv6 seriously. So this is what it's about. In this particular tutorial, I'll go over setting up IPv6 using PrivateLink. And this was a fun one. I spent 2 weeks on this. So let's go. Today, I am going to cover a little bit on IPv6 with PrivateLink. I am using IAC. This is the mission, Infrastructure as Code. And my mission today is really just to show you how I am using my lab to become familiar with IPv6 and show you how to use my scripts. The goal is for this VPC here to send traffic to that VPC over there, and it's going to use the PrivateLink. And as you know, PrivateLink is a regional service. This means that you cannot inter-region support is not there, but there's a workaround, which is to create a VPC peering link, inter-region that is, between VPC3 and VPC1. We'll create that. VPC3 will send data to VPC1 endpoint. We'll create an endpoint here, and that would send the data over to our service. And all of this will be done using IPv6. So in this process, I learned a lot of things. It was great to know that the network load balancer, you can quickly find out what type of features an API can cover. Just understanding the APIs gives you great insight on what you can do with a particular service. Like in this case, for example, for load balancer, when we create load balancers, these are all the options available, right? It's right here. So for me, trying to work with IPv6, I know that IPv4, you have a choice for IPv4 only, but if you choose to work with IPv6, dual stack is the next option. So this is telling me that your network load balancer is going to use both IPv4 and IPv6. So the support for IPv6 only is not yet there. Probably going to be something in the future, not sure. And again, back here, what else am I missing? So another thing is when you have an IPv4 only VPC, when you decide to create, to enable IPv6, AWS is going to provision a /56 network for IPv6 that is yours to use, for the life of your VPC. Of course, you're going to use that, and then you can divide those into /64 subnets for your IPv6 subnets. Now, when you create, fact is when you enable this, the existing subnets do not become IPv6 automatically, right? So you have to create a subnet. You can decide if you want IPv6 only subnets or if you want IPv4 and IPv6 together in one subnet, right? Or IPv4 only. So you have those choices, which is really cool. So within the VPC, you may have subnets running IPv4 only, some running both v4 and v6, and others running v6 only. So you have that mixture of subnets that you can experiment with, depending on your use case, right? So what else? I think that does it for now in terms of just a little bit of nuggets on IPv6 and AWS. All right, so next what we'll do is let's get started, right? Let's play with this thing a bit. So I've created some scripting related to this. This page, the link is on the description. So you can easily go to that link and get to this same page and follow along. But what's happening here is that we'll create the following resources, right? For you at least. What you care about, you're going to create the 2 VPCs, right? You're going to create an additional VPC in US-WES2. Is going to have all the VPCs will be enabled for IPv6, right? We'll have subnets specific to IPv6 and IPv4, so they call those dual stack subnets. those will be in a route table that I call protected route table. The reason I call it protected route table, that will be for the next sprint. But this is when we'll create egress only internet gateways. And this is for us, if you have an IPv6 subnet and you do not want public traffic reaching your instance, which is IPv6 enabled. IPv6, once it's enabled, it can route, right? It's globally routable. It can go out to the internet with the same IP on the interface. So this is one of the reasons some people might be afraid of it, but IPv6 is truly simple. Yes, of course, the IP address can throw you off a bit, but when I say simple, it is based on the headers, right? If you look at the IPv4 header compared to the IPv6, IPv6 is simplified and just much simpler to work with. So that's the reason why I say it's much simpler. But anyway, what I'm trying to say here is if you don't want traffic from the internet reaching your resources, which have IPv6 addresses on them, what you can do is you can have an egress only internet gateway, which behaves a little bit like a NAT, but this one is specific to IPv6. So your resources can reach the internet, but nothing originating from the internet can reach those hosts, which is great. That's why, and again, my route tables, I label them as protected route tables because yes, the routing there is protective. It's only allowing egress and nothing ingress. So and this is going to help you with your migration and easily adopting this new version of IP addressing, which is necessary because, as you know, it is a mandate from the government to make sure IPv6 is used. So this is good. It's a good start for you to pick up this skill set. And of course, as it becomes more used and widely used around the world, is a good skill set to have. So enough with that. Let's get started, right? Let's go. All right, so we are creating the resources, those VPCs. We'll create inter-region peering that will be created. We'll create a dual stack network load balancer. I went over that. And then we'll have two instances created as targets, and they're going to be associated to a target group. Then we'll also have 3 instances created, one in each of the VPCs as private instances, and those will be able to speak IPv6 as well. Of course, flow logs, it will be optional for you if you'd like. There's a script for flow logs. So in my demo, I'm going to use flow logs, of course. NAT gateway is optional. If you need it, you know what to do. You just have to refer to this page and see what scripts to use. So for me, this is the script I used, right? But I'm bringing up the terminal. This is what I'm using. I'm going to run. Of course, this is different from my previous demo on VPC flow logs. Like I said, this is a project that's always going to keep changing, but in a good way. So this is now more modular. By this, I mean you have a script specific to VPCs. This is going to create the 3 VPCs. Then this one will create the subnets, right? The IPv6 subnets that we need. This will create the flow logs. Of course, this is for the connect endpoints, the network load balancer, VPC peering, and then the instances. So I ran this already, and there's a little bug which I want to cover here just to give you a heads up. And again, we working backwards, right? All of this is going to evolve and become way better than it is right now. So right now I do have these VPCs, right? Of course, 1, 2. If I go to Oregon, which is US West 2, same thing. All right, so I have VPC 3 there. Subnets were created, great. Route tables in there. All right, the one I mentioned, protected IPv6 route table. And again, I'm working with 2 AZs, 2 availability zones. So that's what I'm working with. Internet gateway is there. This is Oregon. US OS 2. No elastic IPs, no need for it here. Of course, manage prefix list. Yes, it's there. No endpoints. Yes, I'll take that back. Yes, we do have a connect endpoint. This is for us to access our instances once it's created. So that's good. Shouldn't be no endpoint services, no NAT gateways. There's a VPC peering connection, which is created here. But this is what I want to talk about. If I go back to US East 1, you can see here it's not labeled. And this is something I need to work on. I need to do some fixing there. But this is why now we have to run that script again so they can actually finish the job, right? Another thing is, let's go over to EC2. So under EC2, you can see here the load balancer was created, which is great. The target group were created. Nice. So that was done. Let me see if we have targets. Yes, so we do have the instance, the targets created. This is great. All right, everything was created. So for me, the only thing I need to run again then is VPC peering. All right, so that's done. Let's come back here and we refresh. All right, so now we have it created, active. Good. So now we have a peering connection between these two VPCs. We have a private link. Let me check that if that is the case. So here I am in US East 1. Let's look at endpoints. Yes, I do not have the endpoints. And of course, yes, I do not have the endpoint service. So that is what's missing. So for that, you need to run this script again, all right? So if you remember, and again, a step back, you need to run the VPC peering lab and the ELB one more time. All right, let's make sure the resources were created. So endpoint service, all right, we have the endpoint service created using 2 availability zones, of course. Yep. And let's look for the endpoint. Yep, the endpoint was created as well. And of course, it's in 2 subnets, looking good. All right, so now we can test this thing out. So we've created all the resources that we need. Now we need to test, right? So all of this is there, it's created, no worries. Now I'm going to connect to my targets. I'm going to enable the service there. The communication is happening on TCP port 5555. That is the port that I chose for this. So I need to go in here and enable that service so it can start listening to 5555. And this is what this is going to do, is also going to allow the network load balancer to, to perform heartbeats against the targets, and that will qualify them as healthy targets. So we'll go over that. So I'm gonna now the next part, start with the targets, right? Let's do that. All right, so let's go. I'm gonna start with this one. I'm going to connect. All right, so that's one. Let me connect to the second one. All right, so here I am, I'm connected, and I'm going to use one of my favorite. You can see the targets, you can see the IP addressing, right? V4 and V6, that's cool. Next, I need to enable the service because right now the service, the target groups, see it's unhealthy, right? Because the service is not running, it's not listening on TCP port 5555. Therefore, it's not going to work. So, all right, so I'm going to use tmux, my favorite. I'm creating a session. I'm calling it ELB. Please look up tmux. Call it ELB. I'm going to split the screen, and here I am going to enable the service, and I'm going to use the bind to make it listen on IPv6. All right. I'm going to repeat the same here. All right, so they're both listening, which is great. While they become healthy targets, let's connect to the remaining instances. So right now we've connected to these two. We've enabled the service. While they qualify as healthy targets, I'm going to connect to the remaining instances. I'm going to connect to the instance in VPC1 and the instance in VPC3. So I'm going to go to US West 2. All right, so here we are. Here, I'm going to use tmux, of course. And one thing I'm going to do, of course, I am going to need a notepad. Yes, so this is VPC1 instance, and this is VPC3. Here, what I'm looking for is the IPv6 address. Yeah, so that's the IPv6 address for that one. This is the IPv6 address for VPC1 instance. Let's connect. All right, so let's do this. First thing I want to do is, this is instance in VPC1. What I'm going to do is test connectivity to the instance in VPC3. There you go. We have traffic. Nice. It's responding. Then I want to make sure the service is working, at least from this perspective, right? Key is, right now we're here in VPC1. We're testing the connectivity across the inter-region VPC peering, and we have connectivity to VPC3. Now I'm going to, again, from the same instance in VPC1, I'm going to test connectivity across the private link to the service, right? That's the next step. Let's first make sure the service, the targets are now healthy. Let's go to targets. There we go. Yep, it's healthy, very nice. So we have healthy targets, in one in AZ USC's 1A, the other in B. This is great. So for that, I'm coming back to the endpoint, right? VPC1, it's in VPC1, the endpoint. I am going to copy the endpoint DNS name, all right? Keeping it simple here. There's a lot of things you can do with private links, but this is just for simplicity, demo purpose, showing you that you can actually have end-to-end connectivity. This is what this is about. So let's go here first. Let's see if we can resolve this DNS name. And look at that. So here it's resolving to both IPv4, right? You have two AZs. So each availability zone is going to give you an IPv4 address and an IPv6 address. That is so cool, right? So we have the IPv4 version there and IPv6. Now, remember I probably mentioned, not long ago about the simplicity of IPv6 compared to IPv4 related to the IP header, right? The IP header is completely different. Well, simplified, not say completely different. It's just simple. Please look that up. It's out of scope for what I'm trying to do here. But look at the IP header, compare IPv4 to v6 and not. It's a lot of things out there that can, guide you through it. But it's very simple. And what that means is when you have a destination, right, that is enabled for both IPv4 and IPv6. In our case, this service is enabled for both IPv4 and IPv6. The source here in VPC1 is also enabled for both IPv4 and IPv6. Now, when you are going to a destination that has both IPv4 and IPv6, and the source is also enabled for both, the routing is going to prefer IPv6 over IPv4 because of that simplicity, right? There's not so many things to process at the IP header, and this is where IPv6 is much simpler, and just the way it is. It was created with a lot of thought into it to solve a lot of the complexity or limitations that IPv4 did have, right? It was not just about the number of IP addresses, but also about all the other things. For example, fragmentation is not handled by the routers, is handled by the end devices, right? So it took away that from the router having to, hey, do I need to chop this? No, it's all the end host. You figure that out, right? Really cool. That is just one of the many examples. But anyway, let's get back to this before I get carried away. All right, so now our goal is we're going to test this, make sure this is working. I'm going to use one of my favorite utilities, Netcat. So we'll do this. Yep, I'm going to paste this. And we are going to port 5555. In case it times out, we're going to wait 3 seconds and say it times out. Let's see. Hey, success. We have connectivity. Now, the next thing I want to do is I want to create some data for this. I want to run this in the while loop to have some data to to give us something to look at in CloudWatch. Okay. Sleep 1 second and we'll be done. All right, success. And just to tell you why IPv6 was chosen, you can tell, right, which IP is resolving to IPv6. So it is choosing IPv6 to get to the service. All right, so that confirms what I was talking about simplicity for the protocol. Next, I'll go over here in VPC 3, right? Now we're here in this VPC, and first thing I'll do first is ping VPC 1. There we go, we have traffic. Awesome, right? This is cool. Next, the very next thing to do is, of course, I want to do the same thing. Instead of repeating myself, let me come back here. Stop this for a second. Oops, maybe not. I use Control-C. All right, let's make sure first, can they resolve, right? So let's do this. All right, and yes, VPC 3 can also resolve the endpoint, which is located in VPC 1, right? So here, in VPC 3, we're able to resolve the IP address, the endpoint, which is in VPC 1. This is all happening across the inter-region peering. All right. So with that, now we can take this command. So we can let this run. It's great. Success. And here as well, we have success. It's working, and this is really cool, right? It's for me, it's really exciting. It took 2 weeks to script all this together just to get this result. I learned a lot. It was challenging. One thing I learned, for example, the instance connect endpoints. Right now, you have to create them in a subnet, and that subnet must have IPv4. So it's not yet ready for IPv6 only subnet. So if you need to use connect endpoint instance, you must have a subnet that has both IPv4 and IPv6. So that is something I learned quick. And for the load balancer, yes, dual stack is the way. So for IPv6 only type of communication, yes, getting there, right? So you can see some things still need you to have both, but, and again, this is all subject to change, of course. So to me, get into it, let's start a project, right? Look into this, start a project, start changing, maybe adopting it internally, right? Like right now it's endpoints. So this is not external connectivity. This is just within your infrastructure, or you and your clients. You can experiment, have some services running with IPv6 and create a private link with that, dual stack private link, and allow connectivity to it. So that's just, give you a few steps ahead of the curve, right? That's really what it's about, because technology evolves. So what is now is going to change tomorrow. But, and again, it's exciting to see this working as expected. So here we are in this VPC, we had traffic all the way to the service, and it's working great. It's all IPv6. So next, I'm going to talk about the monitoring piece, which is interesting because I discovered some things. So I want to go over that. Let's do that real quick. Hopefully time is in our favor. Let's do, so I'm gonna go over to CloudWatch. All right, so CloudWatch, of course, log groups. All right, so I'm gonna go here. This will be VPC1. I'm gonna go to search all log streams. Great. All right, so we are looking for some traffic. Let me go over to this. Well, by the way, if you have not checked this out yet, please check it out. VPC flow logs, showing you how you can just look around flow logs using flow logs, and this is all deployed using Python Boto3. All right, let me grab these syntaxes. We want to need those. So this is flow logs, and this one is logs insights. Good. All right, so let's see some traffic related to port TCP 5555. We're at VPC1. All right, here we go. We have some traffic. You can see there we have some traffic. Now, how about we identify where it's coming from, right? So you can tell that traffic here is for the VPC1 instance. We can see traffic there, right? Good. So again, this in IPv4 we call them octets. Here's hextets. But anyway, this here is basically identifying the VPC1 instance, sending data to the endpoint of port 5555. If I wanted to identify traffic coming from this, let's see if I place the source. Source address, destination. Hey, why there's no traffic yet? Good. Maybe the data is cooking. Good. All right, let me try something. I want to make sure my syntax is correct. So let me filter on just this. Oh, so the syntax is wrong. Okay, so forgive me on that. The syntax is not right, so do not use it. But you can look for the ports. You can see that in the flow log. So this right here could be, it's not too clear, right? Now, another thing you can do is we could use Cloud, logs insight. And logs insight, first thing is, let me zoom in on VPC1. Flow logs, the reason why we're focusing on flow logs in VPC1 is because it's right here in the middle. I mean, yes, it could go right here first. VPC3 confirm that traffic is leaving. This is in case of troubleshooting. In our case, this is working, right? But if you were troubleshooting, yes, you could start here. But for me, this is a good place because it's in the middle. It's the gateway for this and also for that, right? It's in the middle of both. So this is why I'm looking at everything happening here. So there's the flow logs. And now I want to do this. All right, so bytes, sum of bytes, source address, and we're looking for address like, right, this is now gets fun with IPv6. So I'm going to be looking for what's coming from VPC3. So it's going to be this but it's not going to be a destination. It's going to be source, right? So source like this guy going to this port. I'm going to limit it to 10 for now, and let's run this query. Hey, there you have it. We have some traffic, and yes, from VPC3 instance, right? Yep, we have traffic going to the endpoint, and you can see that it's load balancing the traffic across both AZs, so it's taking both, right? This is really cool, right? This is how you can track your traffic using IPv6 addresses. It's nothing different than IPv4. The only big difference is getting used to this lengthy, digits, but you will quickly get used to it. All right. So no fear on this. I really encourage anyone, play with this. Use the script. If you run into any issues, hey, just please let me know. But there's one more thing I want to cover. So this right now, we can see data, right, coming from VPC3. From this VPC, it's here going to the service. Great. Now, what happens here? Like, are we still seeing IPv6 addresses, right? That was my curiosity. So because I remember seeing a question somewhere wondering how can you track data hitting the endpoints on the other side of it, right? I thought that you could track based on source port. Well, not so much, right? And here's why. So let's quickly go over. First, I'm going to change the source of the VPC flow logs, right? We're going to change it to 2, right? Because VPC 2 is where the service is. So if I run this once, I'm not going to see, there's nothing, right? 0. Nothing is there. What else can I run here? So there you have it. I didn't go in details, but the scripts are there. If you follow this, you should be able to spin this up and play with it as well, right? So let me know if you get to it, play with it, what you find out. But again, this is going to keep evolving. Next week, hopefully, we'll be done with the scripting for egress only internet gateway, and then we'll talk about that then. But anyway, so I hope you're enjoying this. I hope this is like I would say I hope this is informative. I hope you find this useful. And again, keep learning. This is fun stuff. I'm Pat at Maendeleolab. Until next time, salut.